I'm Anil Kumar. Welcome to my series on statistics. Here are a few questions from previous test paper. We'll take up these questions one by one, and I hope they will help you in your own test. The question here is, a running club organizes a race to select girls to represent the club in a competition. The times taken by the group of girls to complete the race are shown in the table below. So this is the table which shows the data. Part A. Determine the value of P and Q. So these are the two values which you need to find. We are given time taken for the girls to complete the race. So within greater than equal to 10 minutes, less than 12 minutes, 50 girls. And from 12 to 14, where 12 is included, 14 not included, 20 girls, and so on. A girl is selected if she takes less than X minutes. Given that 40% of the girls are not selected, determine the number of girls who are not selected and the value of X. Part C is, we'll take part C in the next page. Okay, let's answer part A and B. So the table provides us the information about the time which girls take to complete the race. So the faster ones will be selected. Faster ones means less time, correct? Now, how many girls are there? Cumulative frequency ends at 200. That means the total of this should be 200, correct? So that should help us to find the value of P. So what we have here is 50 plus 20 plus P plus 40, 20, 20 should be 200, right? Now this is 20 and 20, 40, 80, 100, 150. So P plus 150 is 200. So that gives you the value of P as 200 minus 150. Which is 50. So this is equal to 50. Correct. Now here, this is the cumulative frequency graph points, right? So what should be the value of Q? Well, to get the value of Q, we have to just add 40, right? So we get 120 plus 40, which is 160. So Q is 160 for us. Now let's look into part B. A girl is selected if she takes less than X minutes. Given that 40% of the girls are not selected, determine the number of girls who are not selected. So 40% out of 200 are not selected, right? So 40% of 200 are not selected. Correct? So that means what? That means 40 over 100 times 200. That means 80. So 80 not selected. Correct? So we need to find what? Not selected. So the number is 80. 80 not selected. So out of 200, 120 selected. So we can write here selected 200 minus 80, which is 120, right? Selected. Now, determine the number of girls who are not selected. These are 80 and the value of X. Now, the selected are the fastest 120, right? So the fastest 120 will be this group. So that is the cutoff, right? Now it clearly says a girl is selected if she takes less than X minutes. So less than X, we need to find what is X. So here less than X minutes means less than 20, right? We are selecting this group, less than 20, right? So it means less than 20 minutes. So that means X is equals to 20 minutes. Clear? So the value of X is 20 minutes. Now let's look into part C. The girls who are not selected but took less than 25 minutes are allowed another chance. The new times taken by these girls are shown in the following cumulative frequency diagram. How many girls were allowed another chance? That is first part. Second is find the number of the whole group who were selected. So what we are trying to say here is those who did less than 20 minutes, so let's get back to our original data. So they were selected, right? Now we're looking into those which are below 25 minutes, right? So this data given to us is, so that point here given to us is actually, I'm not shown here, is for 30. Okay, so that is 30. So that should help us. So it says the new time taken by these girls are shown in the following cumulative frequency graph. So that is the frequency graph, cumulative frequency graph, in which timings for each girls are shown. How many girls were allowed another chance? So in this graph, 30 girls were allowed. So we can read from here actually. So there were 30. So how many girls were allowed? 30 were allowed. Find the number of whole group who were selected. So earlier we selected 120, right? Now, who will be selected? So the selection criteria is that time should be less than 20 minutes, correct? So from this graph, that is the time and that is the number of girls. So there are 20 more. So our answer is 120 plus 20, which is 140. So a group of 140 girls has been selected in all. Doesn't make sense to you, right? So that's one question. Now we'll take a couple of questions on box and whisker plot. We'll see how to read box and whisker plot and how to plot one. So I hope with this you get good review on statistics. Thank you. We'll discuss how to read box and whisker plots. 3 relevant questions from previous test papers are being shared. I hope you'll benefit from these. Question number 1. The following box and whisker plot summarizes the results of a test out of 100. Complete the following statements. A. The middle half of the class scored between dash and dash. B. The range of the data is what? C. The top 25% scored at least how much? And D is the lowest mark was what? You can directly read the information and write your answer. Here is question number 2. The following box and whisker plot shows the number of text messages sent by students in a school on a particular day. A. Determine the interquartile range. B. One student sent K messages where K is greater than 11. Given that K is an outlier, determine the least value of K. Here is question number 3. The following box and whisker plot shows the marks obtained by boys and girls in a math test. Compare the information and write your observations. So that is for boys, this is for girls. First question here is, label the plots showing lowest score, lower quartile, median, upper quartile and highest score. Question B is, compare the distribution of each data set in context. So now you can pause the video, answer this question and then look into my suggestions. Let's look into their solutions one by one. Here is the first one. In question number 1, we have these 4. So the values, let me write down. The lowest value here is 20. Then we have this number as 30. Here we are showing this as 62. This is 70. And that is 90. Okay. So with reference to these numbers, we are going to answer all the questions. A. The middle half of the class scored between what? When we are saying middle half, we want to show between 30 and 70, right? So this is the middle half. So the answer here is from 30 to 70. Clear? The next one is the range of the data is what? Now when you want to write the range, in that case, we are actually considering from the highest to lowest. So this is range. So in this case, the range is from 90 minus 20, which is 70. Now the question here is, the top 25% scored at least what? Now this is the bottom 25, this is the middle 50%, and that is the top 25%, right? So this is your top 25%. So when they say at least what, so the least mark here is 70. This is top 25%, right? So least means on the left side, correct? The last question here is the lowest mark was, so that was 20. So this is the lowest mark, correct? So in any box and whisker plot, there are 5 very important things. Lowest, right? So let me write down. So we have 5 important things. One is the lowest. Then we have the highest. Then we have first quartile. This is median or sometimes referred to as second quartile. And then we have third quartile, right? Anything in between which we represent as this particular data, middle half of this gives you inter-quartile range. So that is your inter-quartile range, right? Now these are important informations which are always there. So I hope that is absolutely clear, right? So now let's move on to the second question. Second question here is, the following box and whisker plot shows the number of text messages sent by students in a school on a particular day, right? So first question here is determine the inter-quartile range. So what is inter-quartile range? It is a difference between Q3 and Q1. So inter-quartile range is, so this is your Q1 and that is Q3. So when we say inter-quartile range, we'll say Q3 minus Q1. So in our case, it is 11 minus 4, which is 7. So in our case, the inter-quartile range is 7. Clear? Now, part B is, one student sent K messages where K is greater than 1, right? So on this side, given that K is an outlier, determine the least value of K. So, how do you find an outlier from the given information? So whenever we are talking about outliers, we are comparing the value which is 1.5 times inter-quartile range. So that value plus or minus. So that is what outliers are. So in our case, the inter-quartile range is 7, right? So what is 1.5 times 7? That is what we are looking into, right? So basically, we are looking into 1.5 times 7. 7 means half of 7. So that would be 7 plus 3.5, correct? So which gives you a value of 10.5. Is it okay? So when we say one student sent k messages where k is greater than 11, that means we are on this side, correct? Greater than 11. Given that k is an outlier, that means it has to be 11 plus 10.5. Is that clear? So that gives you 21.5. Now see, when we are talking about messages, we cannot send half a message, so that has to be rounded up to 22 messages. Does it make sense? So therefore, the answer for B is 22. Is that clear? So remember, outlier is calculated as 1.5 times the interquartile range. So we could have outliers on the right side and even on the lower side, right? So in this case, we were asking for k greater than 11, so it is on the right side, and number of messages cannot be a fraction, so we round it to a higher number. Is that clear, right? Now, we have already covered very important aspects. Here is the summary. Question number 3, you need to compare the two box and whisker plots. Now you need to utilize all the vocabulary learned so that you could actually explain the two boxes clearly and also compare them. So whenever we are comparing box and whisker, we have to plot them on the same scale, right? So that has been done already for you. So let's read the question once again. The following box and whisker plot shows the marks obtained by boys and girls in a math test. Compare the information and write your observations. So it seems that the marks are from 100. So let's assume that. Now let's write down some values. So as far as the boys are concerned, the lowest value seems to be around 17, right? So this seems to be 17, that is 20. Quartile 1 is around 40, this is 1, 2, 3, 4, 44. The middle value here is 52, and Q3 is around 60, 66. Okay. And the highest mark seems to be 92. Right. So these are the marks for the boys. As far as the girls are concerned, the values for the girls are, this lowest value seems to be 12, and then here we have 40. The middle seems to be 43. Q3 is 52, and the highest mark is 95. So those are for the girls. Now we have these values. Let us compare them. Part A is label the plots showing the lowest score, lower quartile, median, upper quartile, and highest score. Well, that we did, right? So you just need to write down the title if you need to. So this is the lowest score, right? Here we have first quartile, this is the median, this is third quartile, and that is the highest score. Okay, for both we have done the part A. Part B is compare the distribution of each data set in context. So that is kind of very important. So what are the good points which you could say? Well, clearly, you can see that the bulk of the boys did better than the girls. That's absolutely clear from this data. So that is the 50% of the boys. So you could compare and then say that. Now, whenever you're trying to compare, it is better to use the technical terms and then write down the description, right? So this block here represents the most representative half, right? So what we see here is that the most representative half of boys scored higher than the most representative half of girls, right? So that is one good point. So we're looking at the interquartile, this region. This is wider, right? And therefore, we can write down here that most represented, most half, because this is half. This is 25%, half and 25%, right? So most represented half of boys did better than the most representative, it should have been, half of the girls. Right? So that is as seen from interquartile range. Right? So from interquartile range, you can clearly see that most of the boys, they did far better. This half did far better, and it's on the right side, right? So that is why it is far better. Correct? You could also observe from here that the minimum and the maximum marks were scored by the girls, right? So we could say lowest and highest marks. And highest. Correct, because that is the lowest and this is the highest, right? Now you'll also observe that this block is smaller. That means the representative 50% of the girls were more consistent. So we can say, since interquartile range is lower, right? So we say smaller or interquartile range represents that girls were more consistent than boys. Is that clear? So that is very important, right? So another important thing which you also observe here is that the median is 52 for boys. On the other hand, Q3 is 52, right? So from here you could say that let me use 75% girls scored less than 52%, and 50% boys scored less than 52%, right? So that's a huge difference. So that marks 50% of the boys, right? So 50% of the boys scored less than 52%. On the other hand, 75%, because this is Q3 for girls, correct? So 75% girls scored less than 52% marks, right? So that is very clear from here. So these are the kind of observations which you can make and explain from the given data, right? And of course, you can say that the total range for boys is lesser than that of the girls, you could say. So let me add the last point here. We'll write here total range for boys. You can actually calculate the range and then write down 92 minus 17 is lesser than girls, that of girls, right? I'm writing in short 95 minus 12, correct? So that is how you could actually compare the two and describe them. So we have to relate them with the technical terms, especially the 5 lowest terms: quartiles, median, interquartile range with links Q3 and Q1, the highest marks. Perfect. So if you kind of answer like this, you can probably get full marks. I hope that helps. We'll try to understand how to plot box and whisker plot using the given information. The question here is, in a sample of 50 boxes of light bulbs, the number of defective light bulbs per box is shown below. So the number of defective bulbs are 0, 1, 2, 3, 4, 5 or 6, and number of boxes with those many defective bulbs are 7, 3, 15, K, 6, 5 and 3. So that means there are 6 boxes with 4 defective bulbs. Okay. Now what do you need to figure out? 1. The value of K itself. Determine the median, which is Q2. Determine interquartile range, that means both Q1 and Q3, and then draw box and whisker plot. So you can actually pause the video, answer this question, and then look into my suggestions. So let's begin with the very first one. We need to find the value of K. We know the total number of boxes, right? So we know the total here of the boxes is 50. So that is simple. We can just add them all to 50. So we have 7 plus 3 plus 15 plus K plus 6 plus 5 plus 3 equals to 50. Correct? So that gives you 10, 25, 30, 39. So that gives you K plus 39 equals to 50, or we can say K equals to 50 minus 39, and that gives you the value of 11. So we get K equals to 11. So that's our first answer, which is K equals to 11. Now the second question here is determine the median. So median is the center value. Even number of data, we have 50 here. So to find median, we'll do 50 plus 1 divide by 2, right? So we get a value which is between 25 and 26, right? So we'll say 25.5. So between 25 and 26, we are looking for that value. So it is better to actually make a cumulative frequency from here. So let's add, that will help us, right? So we have 7 plus 3 is 10, 10 plus 15 is 25, and when you add 25 to 11, you get 36. This gives you 42, that gives you 47, and this is 50, correct? So what do you notice? The number which you are looking is 25, that means it could be here or there, right? So between these two. So that means the value of Q2, or you can say median, is basically equal to 2 plus 3 divided by 2. So that is 5 divided by 2 is 2.5. So 2.5 is your median, right? Now, let us look into interquartile range. C is interquartile range. So interquartile range will find Q1. Q1 will be 51 divided by 4, right? Quarter. So that is the position, right? So we'll see in which box we are going. So we are looking into the boxes, right? So the number of boxes, and then we'll find how many are defective in that. So that is basically half of 25.5. So 4 goes 1 times. So you get 10 2 times, and the decimal value 1130. So let's say 8 times or something like this, right? So what we are looking into is a value which is 12.8, not after 12. So between 12 and 13, we say between 12 and 13, right? So if you go into this group, so we have this interval which gives you Q2. So Q1, sorry. So Q1 is 2. Now let's find what is Q3 for us. So as far as Q3 is concerned, so we have Q3, the number lies, it is between 12 and 13 from the right side, right? So you could do this as 51 times 3 over 4, right? So we could do this, that is the number we are looking for. So we'll just multiply this by 3, right? Okay. So that gives us 3 times 8 is 24, 2, 3 times 2 is 6, and 2 is 8, and 3 times 1 is 3. So we're looking for a number which is 38.4. So 38.4 will lie in this group. Correct? 38.4 will lie in this group. So Q3 for us is 4. Q3 is 4. Now, what is interquartile range? So interquartile range is Q3 minus Q1, which is going to be 4 minus 2, and that is 2. So interquartile range is 2 for us. Now let us sketch the box and whisker plot. Okay, so we have this data which goes from 0 to 6. So we have this box here. So in this box we figured that the value of interquartile range is 2, Q1 is 2. Okay, so Q1 is 2, so this is 2 for us. And Q3 is 4, that is 4 for us. And median is 2.5. So median basically is much closer to this side. So that is 2.5. We'll write here 2.5. The maximum number of defects was 6. So we'll go this much units out here. So that is 6 for us, maximum number of defects. And the minimum is 0, so 2 less. So that is it. So that becomes the box and whisker plot. So that is the highest value, highest datum. This is the lowest datum. That is Q1, this is median, and this is Q3. So I hope the whole process is absolutely clear, how to figure out the quartiles and interquartile, and figure out and how to sketch the box and whisker plot from the given data. I hope that helps. Feel free to write a comment, share your views, and look into other related videos, and all the questions have been taken from previous test papers. So they should be very helpful. Thank you and all the best.